everyone, so now let's do this one. How we can say what are the tools we have to check the network issue. Generally, whenever we have any problem in the network, we can use the debug or conditional debug. But in real scenario, 90% we are not going to use the debug and conditional debug. This one and this one we are not going to use 90% in the real scenario. For lab purpose we can use, but in the real scenario when we don't have any other option, at last we are using this debug and conditional debug. Why we don't want to use this one? Because when we enable the debug, our CPU will go high and maybe our router or the switch is going to start reloading, restarting like that. Switch off, switch on, switch off, switch on. To overcome, and our link will go down. So to overcome these types of issue, we are not preferring to use the debug command. But at last, if we don't have any solution other than the debug, then we will use the debug. Okay. And also one more thing, we cannot use ping also in the real scenario. We can use the ping, but if your firewall is there, example, imagine like this way, you are, let me take, this is the switch. I am drawing a small scenario. You are here and it is connected to your firewall. This is firewall, and then you have here maybe internet, and this is a firewall IP. Example, this is a firewall IP 192.168.1.100, and here you have 1.1. and example, you are trying to ping this interface. You are checking I can ping, my connectivity is there or not. You are pinging this interface and you are getting replied request timeout you are getting here. You are unable to ping, but when you try to ping the Google server, you are getting the reply back. So you are saying my firewall I am unable to access, but I am able to access the internet. Why like this? So because by default the firewall interface we cannot ping. They are disabling firewall by default. They disable the ping in this interface. We can enable if we want. We can access the firewall. We can create the profile for the ping and we can add that profile to this interface and this interface. But generally in the real scenario we will not enable the ping here. So ping will be not enabled. So most of the time we are not using ping command to do the troubleshooting in the real scenario. But for the lab purpose, in the exam purpose, we can use ping trace route. And in the small organization, depend organization to organization, some organization we can use ping command and the trace route, but most of the organization they disable the ping in the network, so you cannot ping also. But as they mention in our syllabus, this is also one of the tool. We can ping and check. Ping is reply is coming means connectivity is there. If reply is not coming means connectivity is not there. But we don't know if in between somewhere, if in our network, if anyone block the ping, maybe network guy, any network engineer block the ping, so we are unable to ping also. Okay, so in the real scenario, this one we will not use, this one we will not use, and trace route we can use, depend if they block or not block. And ping, most of the organization block the ping, so we cannot ping also. Like if you see any website, most of the secure website, you can what we can say, you can access the website, but when you try to ping that website, ping will not reply. Ping is not allowed, but you can access the website. This because they want to stop the DOS attack, deny of service attack. Because if they are sending lot of ping, the server is having the issue. The router CPU is going high because someone is trying to ping that server. They are sending a lot of traffic to server. For that purpose, they will deny also. But they mention in our syllabus, so we are going to see that all. But remember, in the real scenario, what we will do, we will use the telnet. We will use the telnet to do the troubleshooting. Telnet. Maybe you are thinking how we will use the telnet. Telnet we are using to connect the device remotely. But in the real scenario also, we will use the telnet and we will write the IP address, whatever the IP, and then we will write the port number to check the connectivity. Because in some time we will don't have ping not allow in the network, trace route also not allow in the network. So in that scenario we will use the telnet. Example, I want to check. Okay, let me show you how I can check. I can go here in the CMD in the command prompt, and I want to check here the Google server. So I will write telnet, and I will write here google.com, and then port number 443 I am using. So when I write, and if you are getting the black screen, that means connectivity is there, telnet is working. Okay, let me repeat again what I am saying. We will write telnet and write the IP of that one. Example, I will write ABC, any invalid, and then 443, and when I press, you will not have black screen, means you don't have the connectivity to that ABC. See, you don't have any connectivity. What we are getting, open connection to the host, on this one connection fail. But if I type this one, it is working. You have the black screen. Black screen means connectivity is there. So in the real scenario, we are doing like this way. In the real scenario, but in CCNA, CCNP, no one will teach that way. That the what we can say, that telnet we use, because in our syllabus that is not mentioned. In our syllabus, just they give this what we can say, debug, conditional debug, trace route, ping, SNMP, syslog. But as we are doing that one, so I am explaining you. In the real scenario, we will use the telnet. What we will do, we need to write the telnet, and then you need to write the server IP, whatever the server IP. So I am using Google, so I will write Google. And which port you want to check, on which port it is working or not. I am checking 443. Why I am using 443? 443 is nothing but HTTPS. If I write here what is 443 port is used. If you see what is a 443 port is used, so you will see HTTPS. HTTPS is nothing but 443. If I write here instead of HTTP 443, if I write port 80, that is nothing but without S. Okay, without S. If you see, port 80 means HTTP. If port 443 means HTTPS. So this one we need to remember, because when you are working, they will ask you like maybe you have the ticket for the troubleshooting. They will give you source IP, destination IP, and the port number of the destination. So with that one you can check. Like example, you have one ticket. Your manager told you, your manager will tell you that, example, let me show you. Your manager will say one user, example, this is one user, and this is your firewall, router, whatever you have. Then you have your internet here, you have your internet connection. Your manager told this guy, ABC guy, is unable to access port 80. So generally you will have the ticket. What ticket you will have? Example, this guy is having 192.168.1.1. So in your ticket, you will have the source IP. In the ticket they will mention source IP 192.168.1.1. destination IP, they will mention in your ticket destination, example 8.8.8, that is a Google, and port number, destination port number. They will mention this. In the real scenario, you will get the ticket saying that this source is unable to access this server on the port number 443 or port 80. Port 80 means HTTP. HTTP means port 80. HTTP S means port 443. So generally we are using 443 only, not the HTTP 80. So imagine you have the ticket. Your manager told this source IP, this is the destination IP. They are unable to access this one on this port. Can you check? Maybe you are new engineer, you join new company. So what you will do? Okay, I will ping. You are sending the ping here. Maybe you will ping this router. You will check, I can ping my gateway or not. You will see, okay, I can ping this router. Then you know the IP address of your firewall. So what you will do? You will ping this IP of the firewall, and request will not take, reply will not come. Why? By default, firewall all interface ping is disabled. By default, firewall all interface ping is disabled. So when you ping this one, reply will, what you will have? Request timeout. Then you will say, okay, you will inform to your manager that I found out already the issue is in our firewall. So manager will tell you another guy is able to access. This is the another guy. He is able to access. If there is any issue in the firewall, 192.168.1.2, this guy is able to access this same services, only this guy is unable to access. Then how we can troubleshoot? So what we can do for this scenario, I will go here, I will go to this guy and I will type here in from this PC, I will write telnet and which destination IP he need to go, example 8.8.8, and which port, I will write this 443 and I will put enter. If you get the black screen means connectivity, no problem, he can access this server. If you are not getting black screen, if you are getting something connection refuse or something, then what you will do, you will think okay, some issue is there, maybe something wrong with cable, anywhere it is dropping, or maybe this server is not working. So in simple, what you can do, you can check what server he is going to access. That server is available outside. That server is available outside. Outside means the server 8.8.8 server is outside our organization. So easy and simple way to check this one. Just open your mobile or open your personal internet and try to access this one. If you can access means something wrong in our network only. But even if you are opening your personal internet and you are checking, you cannot access this one means, then you can reply to that ticket saying that this server is down. Whoever is maintaining this server, report them. We cannot access this server even from our company network and also from the outside that network. Okay. So this way also we can do troubleshooting. In the real scenario I am saying, in the real scenario what we will do, we will first write the telnet and the IP of the destination and the port number. If you get black screen means connectivity is there, everything is good. Maybe something is wrong in our network only. If you are getting here connection refuse or something, maybe we can say internal or external. If internal or external, before checking each and everything internally, what we will do, we will open our net. If that server is public server available for everyone, just you will type this public server, whatever that server in your mobile, and you can check you can access or not. If you can access means server is not having issue, something wrong here. Maybe that guy is not allowed to access in the firewall policy. So in that scenario, what we can use the packet tracer. Packet tracer is a command, not our packet tracer, not the CCNA packet tracer. This is a packet tracer is a different command we are using for Cisco ASA firewall to check the what traffic allow or not. Or for the Palo Alto firewall, we will use the policy monitor. Or in the checkpoint, we can use the TCP dump, checkpoint firewall. So we have different word, but all that what they are doing, with that command we can check whatever traffic is coming by from this PC, it is allow on firewall or not to go there. So we use that command to check that one. But before that one, just try to access that public server with your mobile. If it is not working, then you can directly say this server is not available. Try to coordinate, try to ask the guy whoever is maintaining this server, because we are unable to access this server from internally as well as from the externally, means from outside the organization also. Okay, so this way we can do. But anyhow, as we have in our syllabus, so we can do. Let me remove this, the other thing. So let's discuss what present in our syllabus. So let me go here, this one, debug and conditional debug. So debug and conditional debug are useful tool when troubleshooting we are doing. Whenever we are doing troubleshooting, we are using the debug, and it is very useful tool. It will show us the real-time information, like whatever is happening in the background of the device we can see. Example, if you see this router and this router, both routers are there, but if you see here, I cannot see. Example, let me show IP interface brief. I have here this IP 192.168.65.163. so from R1 I am going to ping that IP. Okay, from R1 I am pinging this IP, I am getting the reply. If I want to repeat, maybe I will repeat 100 times. Okay, so I am getting this one, but here we cannot see anything. But if I enable the debug command here, I can see this packet from the R1 is R1 sending the packet and it is coming to me and I am replying back. I can see with the debug command. How? I will write debug IP ICMP. Okay, I enable now. What I enable? Debug IP ICMP, but don't enable in the production network this one. For lab purpose we will do, but in the real scenario don't do this one. You will have issue, okay? Because here in the lab we have only 1 ping, 2 ping, but in the real scenario you have lot of traffic. In the real scenario you will have lot of traffic, so no need to enable any debug command there. For lab purpose you can do in our what we can say GNS3 or EVNG, we can do this one. And if you see here, before when I am pinging, nothing is showing here, okay? Nothing is coming here. But when I put this debug IP ICMP, I can see this message. What message I can see? I can see here, let me show you. What I can see means this one ICMP packet is coming, echo reply, and this guy 163 is replying to this source. This guy is source 163 because R2 is replying. R2 IP is this one. So source he is replying to this IP. Okay, they are pinging, so this guy is replying to this IP. This guy is replying to this IP. That we can see. So in some scenario we are thinking maybe the cable is broken, maybe the port is broken. So in the scenario, imagine this is one scenario. You have the connectivity issue from R2 or R1 to R2, from here to here. You are unable to access the R2 from R1. So what you will do, you will ping here and you want to check ping is coming here or not. So in that scenario you will enable the debug command here. When you enable the debug command, you can see the messages, whatever messages is going on in the background. But don't enable that in the real scenario. When I enable, I can see that message, I am getting this message. So it is working. So traffic is hitting and this guy is replying, but in between, maybe if you have any firewall or something in between, maybe that device is dropping that one. Or maybe if you have one more router here, that router is not having the address of this one, that's why he will not reply. So we will have different commands, so we will use that one to check internally we are getting or not that message. So how we can check? We can write here debug IP ICMP to check the debug of the ping, and if you want to get the complete IP packet, we can use debug IP packet. We can do the interface also, debug interface, debug EIGRP packet, hello packet. We can write all this one. But if you want to do conditional debug is better compared to debug. Debug means he is going to debug all the commands. Okay, if you write here debug ICMP, he will show you all the ICMP. If you want to see particular only, we can do conditional debug. Conditional debug is nothing but we will give the condition. Like I will say debug condition interface fast Ethernet 0x0. So he is going to show me only debug message for the fast Ethernet 0x0, not all other interface. If I enable debug IP ICMP or debug interface, it will show me all the interface debug messages, but I don't want to see all. I need to check only particular thing, so I can do that one also with the help of conditional debug. Okay, and if we want to disable, then we will write no debug all or you all. Example, if I want to disable the debug here, okay, if I want to disable, I can write you all. When we write you all means automatically they are going to disable the debug. They will switch off the debug. Okay, you all we will use to disable the debug. So why we are using debug? To check the traffic is coming here or not. For troubleshooting purpose we are using that. For the troubleshooting purpose we are using that one. But if you want to run the conditional debug, we can use the conditional debug also. How we can use means we will use in this way. We will get traffic only particular interface. So in this scenario we taken 3 router. Okay, we taken 3 router. We run the OSPF in all these 3 router. An example, in the R2 I enable the debug IP OSPF packet. When I enable, we will see the packets, whatever packets are coming, all the interface, all packets I can see here. But I don't want to see all the interface packets. I want to see particular one interface, so I can write debug conditional interface. Which interface I want to see, that interface I will define here. So I can see packets only for that particular interface, not all the interface. So that is a conditional debug. Conditional debug is better than debug because debug is going to show all the logs and it is going to increase CPU and RAM. At least we can use conditional debug, so we will not utilize that much RAM. Okay, so this way we can use. If you want to disable, we will write no. in the front of that one, so it will disable that one. Okay, so this is a debug and conditional debug. Why we want to use the debug? We can say this is a one of the tool we use to do the troubleshooting. Debug are the useful tool when troubleshooting we are doing. Okay, it will help us to get the information to verify traffic is coming or not. Understand the concept, write with your own, define with your own. Debug, why we are using, and why we are using conditional debug means if we want to check particular traffic only, not all the traffic. And then after that we have ping. Ping we know already. What we can say, ping is used also for checking the connectivity. Like this is also very important and common command we are using everywhere to ping and check our server is working, our router is working, or our internet is working. For everything we are using ping. If we ping reply is coming back means we have the connectivity. But remember the scenario which we told. If you have firewall in between, maybe you will not have the ping. Maybe in the firewall, security engineer maybe disable the ping. So in that scenario, we can use the telnet also. But anyhow, ping we can use for checking the connectivity from source to destination. We have different method. In the ping, we will have this colon, dot, u, q, m, question mark. Most of the time, we will see this one. When we have successfully replies coming means we will have the colon. This symbol, and when we have the request timeout we have the dot, and destination is unreachable means we have the q, and if it is a destination too busy we have the q, and could not fragment then we have m. But most of the time we see first, second, third, these three we are seeing most of the time. If unknown packet type question mark, and if we have the packet lifetime exceed then we have this and symbol. So this is a symbol we are going to get. Example, just if we ping here, I will ping a dot or google.com. Okay, if you see replies coming here, but if we, instead of coming reply, if you have something different, example I will write ping abc.com. maybe we have this domain, yeah, abc is also there, maybe some different name we can write which is not available, like something ddd.com. So if it is not there, ping request could not find this one, please check and identify, because let me take some IP. DNS is giving that one, because DNS know that he cannot translate that one, that's why DNS give that it is not there. Let's see this IP we can ping or not. 33.42. request timeout. Here we will get request timeout, but if we ping, if we do something inside the router, like if I ping here 1.1.1.1, if you see 1.1.1 is working. Why it is working? Maybe we have IP here. Loop back, let me check 2.2.2.2. it will not work. Okay, so now you have the dot. If you see the dot symbol, when reply is not coming we will have that dot symbol. Let me show you this one I am saying. So this way we have a ping, also we have extended ping. Like this is we are doing normal ping, just we will type ping and we will write the IP address. But if you want to put more specific, like you can write ping and put the enter, they will give you define the target IP and repeat ping how many times, how much data you want to send, and after how much time we can say timeout, and how much we need to we need to extend. Yes, means give the source IP, give the what we can say server IP, how much size of header we need. We can mention this detail also if you want to use. That is known as extended ping. But generally when we are doing this one, example, if I write like this way, let me exit this. Okay, if I write ping and press enter, here they are giving you what we need to do with the ping. But if I do in the router, let me show you here. If I write here ping and press enter, they will ask you protocol IP, which IP we need to ping. This one, the one which I am asking. So I can define the IP of that one, what IP I have. I will write enter, so give me the protocol IP. If I don't have, I will press enter. Then target IP, what is the target? Example, I want to ping 192.168.1.1. then I will ping here. Then how much repeat count means how much, how many ping packet you want to ping, maybe 100, so I will write 100. what is the size we need to give. I will say enter means they will take this default value. Time out, how many second, after 2 seconds. Extended command will be just I will press, if I want to increase the size I can say, or I press enter, they will take the by default. Means here depending upon our requirement we can specify how many bytes we need to send, where we need to ping, destination address, source address. We can use that one also. That is known as extended ping. And we have the trace route. Trace route is used to check our packets are going from which location. Example, we have 1 2 3 router here, one server here, one PC here. If I am pinging, maybe it is not working. I want to check my packet is going from here to which router. In that scenario I can do the trace route. If I write here trace route, that is tracer route. In PC we have different command, in the router we have different command. If I write here, let me break this one, this IP, or let me write here, I will write here trace route. In the router we will write trace route, but in the computer we will write tracer T. This command we are using in the computer, tracer T, and we will give the IP address. So he is going to trace how many hop away this one. Example, this is 192.168.1.1. maybe this is the example 12 we are using, 192.168.12.1, 12.2. This is 13.1, maybe 13.2. So all the IP how they are going, they will show us the path. Example, if I use here, maybe I can write here tracer T 8.8.8. okay, when I write this one, it will do the trace. He is going to trace that one. First hop they go, and then they will go to second router. First hop they go to my router, the router which I am using in my home, that router IP. So when I try to ask, maximum they can go only 30 router, okay, because maybe Google server I don't know where it is located. So but here limit is 30 router they can cross, and they can show me how much time they are taking to reach. So from my computer they reach to my home router. From home router they will go out, they will go to the public IP, they will go to ISP router. From one ISP router to another ISP router, they will go to so many places. At last they will reach to the server, and they will show us whatever the router IP in between they found. So same scenario here I put here, where this one. So this is a basic lab we can create in packet tracer. Already I have somewhere here. Let me check if I have this. I don't know what name I save this one. Maybe trace this one. So we can check here also. So configuration what I use, let me show you. Configuration we use, just we assign the IP address on the interface of the router, and we enable the OSPF. Again, next router, if you see, this is the topology which I am using. I am not creating now because this is very simple. We are learning from CCNA level. Just I am giving the concept here. So what we are doing here, this is the router. We have one router, two router, three router. This is a basic lab. We are just assign the IP address to all the router, and we are enable the OSPF, so they have the connectivity. And we can do tracer T from here to check where our packets are going, how they are going. Tracer T, and write the destination IP. Example, this is a destination, so I will write 192.168.2.2. So if you see, it go first, it go to this interface 1.1. After that it will go to this 12.1.1. they go here, okay, and after that it will go to here, and then here, it is having request timeout because OSPF is still not running, because OSPF will take time, because just now we open the packet, so they will make the neighborship. After that it will start working. Let me check OSPF we have or not before I keep OSPF. Now it is in the full state. Okay, before it is not in the full state. Now it is in the show IP route OSPF. If you see, I have the route. Before it is not there. So now again we can send the data. Because when we open this topology, we need to press the fast forward. So this will be running smoothly. Or we need to wait some time. Okay, So let's finish this one so we can ping again. We can trace route again. Okay. So this is the, let me do now. I am doing now again. Okay. If you see now we have all the routing protocol is working. So that's why this is going to this, what we can say 1.1, 12.2, 23.2. So this is going this way. Let me show you where is that topology. This way. It is going here. This interface, then this interface, then this interface. From this interface it will go at last to that place. Okay, maybe they have some issue here. Maybe this interface is not configured or something, we can check. Okay, this way we can do. And if you see, if you imagine if I want to access the server, this server, I will go here in the browser, I will type the IP address of this server 192.168.2.2. okay, and I will press enter. This is the port 80 HTTP. I can access or not. Let's see. I cannot access, so maybe some issue here. That's why we are unable to ping also. So let's go here. Maybe this server is not having IP. Yeah, see, this server is not having IP. So in the real scenario we will have these types of issue. Why we will not have the connectivity? We will check, we will track. I did not remember long before I designed this lab, but now just I think maybe here we don't have the IP, or maybe services is disabled here, or maybe here EAG OSPF is having some issue. So I check. So when you practice, when you do the, what we can say, the job daily routine, we will have these types of issue. Okay. So what we can say here, I will write here 192.168. I will save the IP here. I will, what I can say, I will put the IP address here. Okay. In this router, I will put here 192.168.2.1. Okay. Now let's do again. It will work. Here request timeout. Now it will start. Now it is having the connectivity. And if you check here also, before it is having the issue, but now it will work. If you see, it is working perfectly. Okay, and if we go for one more thing, if I go here, if I write here the IP 192.168.2.2, if I do here S also, this one S also working. Okay, but imagine your server, this is the server, right? So in the services, I will go in the services, and where is the, this is the HTTP. And if you see here, I will off this server. HTTPS server is off. Now if you ping here with the HTTPS, you will not have. Maybe this is old history. Let me go to the browser and I will type here HTTPS here, and then back colon and whatever the domain name or whatever 192.168.2.2. See, server reset the connection. In the real scenario, we will have these types of issue. Imagine your team is complaining, or someone from the different department is complaining, when I am trying to access, I am unable to access. Then you will ping, you will ping. Okay. So what you will do, you will go to that PC and you will try to ping. You will go here, write ping 192.168.2.2, and you will say reply is coming, server is okay, reply is coming, but why it is not working? Then what you will do, you will write here telnet, and you will write the IP of that server 2.2, and you will write the port number 443. And when you write this one, server refuse the connection. So you can say connectivity is there, connectivity is okay, but something wrong in the server. When I am trying to telnet this server with the port number 443 means HTTPS, server is refusing. So we can say, server team, can you look the server? Because we are network engineer, we check our connectivity, everything is good. You can check the server. So server guy check, and they have disabled the services, they will enable now. Okay, they will enable now, and then you can again check here. When you check here, you will get this is working. Open means working. Okay, same thing what I told you here. We will type here, what we will type? We will type the telnet google.com port number. So it will come black screen. Same thing, but here in the packet tracer it will show open or close, but in real scenario you will have the black screen here. So when you check this one, then you will say, okay, now it is working. Maybe server team do something, now it is working. So we can go to this place and we can type here https // here we can write here 192.168.2.2. okay, now it is working. Before it is not working. Why? This server is disabled the HTTPS services. So these types of issue we will have in our real scenario. Okay, so which one what we are discussing in here? So this one we discussed just now, and trace route we told, and this one just now what we are saying, trace route. Okay, and we have extended trace route also, same like this ping we do. We will write trace route and put enter. They will give the IP, source IP, destination IP, how much and what we can say the timeout, all maximum value of the TTL value, time to leave. We can increase also TTL value. So what is the minimum value, what is the maximum value, we can define also if you want to define this. Okay, so this is nothing but extended ping, but in the real scenario we are going to face these types of issue. This is a basic topology just to show you. Maybe here we disable, or maybe this service is disabled and this service is enabled. The guy is from here, this guy is trying to access the server with the HTTP. HTTP means port 80 without S. Okay, without S it will not work because that service is disabled. Without S I am saying HTTP. HTTP means port number 80. Remember in interview they will ask you HTTP means port number 80. So what I can say, I am unable to access the server on the port 80. You are the network engineer, you go there and you ping the server. What you will do, you will ping the server. You see connectivity is good, you can access, but something, so what you will do, let me check the which port you are using this server, port 80. So I will check. Okay, remote connection refused, so something wrong with the server. Then again you will call the server team, system administrator, they will go and they will check, they will enable the service, and then again you will check here this one and it will say open, means it is working, and then you can go here and you can type with the HTTP and the whatever the IP, that is 192.168.2.2, and press, it will work. Okay, so these types of issue we are facing in the real scenario also. Depend, maybe something different also you will have. We face this issue also in the real scenario. Okay, so with this one what we can say, we finish what we finish. Let's highlight here. We finished this problem, debug, conditional debug, trace route. We did not do the SNMP. We have theory here, but anyhow in our next class we are going to do the some lab also for SNMP, but in our syllabus they put only theory. Anyhow in our next class what we are going to do, we are going to do the SNMP and configure, verify net flow, and this one DNS center. So in our next class we will finish this. If possible we will finish this also. So remaining will be automation. Maybe in the 2 class or 3 class we can finish this automation also. Here we have the lab and all other will be theory only. So easily we can complete. Maybe more 3 class or 4 class we can finish our CCNP syllabus. Okay.